Hello again, folks, and welcome back. Now, I want to show you a few of these rules of simplification because I realise these can be slightly confusing. Okay, so we can go through and just prove each one works. So first, we're going to start with the AND gate. So I'm going to draw a quick AND gate here. Look at that, isn't that beautiful, the AND gate? The mushroom that's fallen over. Okay, so imagine this AND gate. Say one of the inputs was A and the other input was 0. Well, because it's an AND gate, because one of these has got no charge, it doesn't matter what A is, the output is always going to be 0. There we are. Bingo banga bongo. Okay, so that's not worked, has it? Okay, so we'll just take out that one. Next, what would happen if I changed the 0 to a 1? What would happen if there was a 1 going in there and A was connected to it? Well, the answer would be whatever A is, because if A is a 0, the output will be 0. If A is 1, then the output will be 1. So if it's A and 1 as the inputs to an AND gate, the output will always be exactly the same as A is. Okay, so that's that one. Perfect, eh? And the next one, we say what happens if both sockets have got the charge of A? Well, in that case, the answer is, of course, A. Why? Because if A is 1, then 1 and 1 will output 1. Whereas if A is 0, then 0 and 0 will output 0. So if A and A are both being put through an AND gate, the answer will be whatever A is. Okay, nice and simple. Okay, let's clear away this AND gate. And when I've done that, I'll draw a nice OR gate. And we can start on an OR gate. Okay, so there we are. It's slightly tricky to draw these are, I feel. There we are. Okay, so if one of these is A and the other is 0, then the output for C, this top one here, must be A. So whatever charge A has will be output there, because 0 will not give you an output. But A could do. If A is 1, being an OR gate, 1 and 0 in an OR gate, will produce 1. A and 0 will produce whatever A is. Okay, so that is pretty much guaranteed to work. Next, what would happen if I said, okay, here I have got A and 1. What would happen with an OR gate? Well, if there's a 1 sitting right there, then the answer must be 1. Why? Because if A is, doesn't matter if A is 0 or 1, there's a 1 there already, so that will give you the answer. So A or 1 will always come out as a 1. Okay? Next one, what happens if we get A and A? Okay, so put the A's in there. Well, the answer is going to be for an OR gate, whatever A is. So we'd say, okay, well, if they're both A, if they're both 1, then the output's 1. If they're both 0, then the output's 0. Fairly simple, really. Right, last but not least, A or not A? To be or not to be, that is the question. Wahaha. Okay, so we've got a not A, and we've got an A there. And if one of them is negative A, or the reverse of A, and one of them is A, then the output must be 1, because at least one pole, at least one of these two poles here will be positive. Guaranteed. Perfect, eh? Perfect. Okay, so there we are. A or 0 will be A or 1 will be 1, A or A will be A, and A or not A will be, yep, you got it, A. Sorry, 1 for the last one. So, last but not least, not. Let's finish on the negative, shall we? So, Where's my rubber gone? I can't seem to get rid of this annoying OR gate. There we are. Beautiful. So we have now got double NOT gate. This, guys, is called double negation. Okay, so basically we take a NOT gate and then we take another NOT gate. What's going to happen if A is input here? What will come out here? Okay, so first A goes into there and becomes the opposite of whatever A is. So say I put a 1 in here, 0 will come out here. If I put a 0 in here, 1 will come out here. But then I put them into a second NOT gate and that will switch them back again. So if I put 1 in here, 0 comes out here, so 1 will come out here. And if I put a 1 in here, 0 comes out here and 1 comes out there. This, guys, is called a double negation, okay? And these rules can be very, very, very handy, as you will soon see, that's better, for simplifying Boolean circuits, okay? So we've learned about the rules of AND gates and the rules of OR gates and the rules of NOT gates. So I will talk to you all soon and see you later. Have a great day.